I hope you are all having a great evening. In this video, we're looking at something interesting and something easy. We have to show that the sine and the cosine functions cycle every 2 pi radians, or you can say that the sine and the cosine function cycles every 360 degrees. What does that mean? If you look very quickly at the basic sine and the cosine, either, not both, but either, you know that they are from minus infinity to positive infinity. They go on either ends forever, and they cycle or they repeat in terms of their repetitive nature. You have a cosine function which looks something like this, and you know it continues like this. If you were to pick a specific point, it could even be, let's just say this point right over here, and it would be repeated right here, it would be repeated right over here. At each of these x-axis values, whatever they might be, you have the same y value, and that y value is right over here. That tells you that the sine and the cosine cycle every 360 degrees. If you were to look at this distance from right here to here, it's 360 degrees or 2 pi radians. And the same holds true for the sine. We have to show you why that is the case. If you were to take a specific value like I'm talking about, and you were to take 2 pi on either side with whatever integer, the sine and the cosine of that value would always be the same to that original value. What are we saying over here? If you were to take a single value sine x or take a single value cosine x, it would also equal to the sine of that same value, and you are adjusting it based on that specific expression that you see. I'm not putting a plus or minus here because I can, because n over here can be any plus or minus integer. If you were to do any of that, it would always be the same. 2 pi 360 degrees multiplied by some factor which is your integer, positive or minus, it'll always be the same because of the repetitive or the cycle nature or the cyclical nature of sine and cosine. We have to show you that to be the case. This, you can think about all of this in terms of a unit circle with the way I've represented. You have a specific triangle that generates, which is a right triangle. You have an x dimension, y dimension, and a hypotenuse. You have a specific point over here which is your x comma y. That is a point on your unit circle. If you were to look at everything here with regards to x and y and the trigonometric definitions, you know cosine theta would be equal to adjacent over hypotenuse. Sine theta here would be equal to opposite to that angle and its hypotenuse, and then x here is equal to r cosine theta. Here y is equal to r sine theta. Now take the same triangle, I'm going to blow it out for you over here. I'm looking at a certain angle over here, I'm looking at a certain point. This angle, you can keep repeating it by a certain, that 2 pi n. You can do it as many times, positive or minus, it doesn't matter. You'll always end up on that same value with regards to 2 pi n because you're doing a certain constant factor, and here's your factor. Whether it's positive or minus, you end up on the same spot. And that right there is why the sine and the cosine are indeed cyclical, but we have to show you that to be the case. And let me show you that. And I can show you best by making a little bit of a room over here. I've showed you that x is equal to r cosine theta, and I've also shown you y is equal to r sine theta. If I make x is equal to r, and now I bring in a cosine and I do theta plus 2 pi n, because I can do a positive or minus in terms of the n. I can do y here is equal to r sine theta plus 2 pi n. That right there, this entire expression over here should be equal to these individual expressions. This here should be equal to that, that should be equal to that, and I'll show it to you to be the case. When you're looking over here, you're thinking about the sum formula for cosine. When you open this specific one right over here, you're going to get cosine. You have a r sitting out right here, r cosine. And then let's put a parentheses here. You're going to do the sum formula, the sum identity of cosine, cosine x plus y. You can have a cosine theta, cosine 2 pi n, minus sine theta and sine 2 pi n. By its very nature, sine of any 2 pi is always 0. All of this zeros out. By its very nature, 2 pi in terms of cosine is always equal to a 1, and the only thing you retain with is a 1. And multiplying with this cosine theta, so you end up again with r cosine theta, which is equal to exactly what you're seeing here, because the expression was all of that. X is equal to r cosine theta. I can bring you the calculator here. Let's look specifically at 2 pi n. If you do 360 multiplied by like a n value, let's say 9, you do cosine of it, it'll be always 1. Take that same 2 pi n take 360 now multiply by like a negative n value. We can do like 13 minus 13. You do the cosine of it, you'll still end up with 1. And that right there is exactly why this entire expression using the cosine sum formula, remember the cosine sum formula was this: cosine x plus y is equal to cosine x cosine y minus sine x sine y. That's exactly what we applied here. We have an x and a y. We applied it here. This zeroed out. But this here became a 1. You retain r cosine theta, which is equal to this. Now let's examine second expression right here, the sine expression. When you're examining this sine expression right here, think about the sine sum formula, which is sine x plus y is equal to sine x cosine y plus sine y cosine x. You know that identity. You got to employ it right here with exactly what you see it. So let me do that. When I bring that identity into place, I have this. I have a sine theta cosine 2 pi n. Remember, n can be positive or minus, plus. I have a sine 2 pi n and cosine theta. By its very nature, sine 2 pi n will always zero out, which will zero this out. But I've already shown you this here is always equal to a 1. This 1 multiplies with the sine theta, and you're left with here y is equal to r sine theta. So the original x is equal to r cosine theta, your original unmodified point, and your original y is equal to r sine theta right here. Your original part of your point is equal to exactly the same angle here with these modifications. The 2 pi n, whether it's positive or minus, and the sine version 2 pi n, whether it's positive or minus. So you can cycle as many times as you want with this angle, so long as you're doing in multiples of 2 pi n. You'll always end up on the same spot. And I've shown you x is equal to r cosine theta, which I erased, but I showed it to you, and y is equal to r sine theta for the modified version and for the unmodified version. So that indeed shows sine and cosine cycle every 2 pi radians or 360 degrees. And that's all I wanted to show you in this video. Thank you for watching. Have a nice day.